Howdy, this is your friendly neighborhood physics teacher here, and we are going to go over the College Board free response for Unit 4. This is energy. So we have the question. This is the first question. This question is a long free response question. It has different parts. So I know if you can't really, I know the picture is very hard to see. It's on black, but you have rocket. This is rocket X is launched upward with initial velocity of v naught. It's going up at t0. So at t equals t1, the rocket X reaches the maximum height. And then at t equals t2, rocket X reaches the ground. It's upside down. So basically at 0, it gets launched. At some indeterminate time, it gets to the top. And then it turns back down and hits the ground at another indeterminate time. So students conduct an experiment to study the motion of two toy rockets. In the first experiment, rocket X of mass mr is launched vertically upward with initial speed of v naught at time t0. So that's this first little picture here. The rocket continues upwards until it reaches a maximum height at time t1. This is this picture here. As the rocket travels upward, frictional forces are considered to be negligible, so we have no friction. The rocket then descends vertically downward until it reaches the ground at time t2. It's here. The figure above shows the toy rocket at different times of its flight. In a second experiment, which has not been conducted by the students, rocket Y of mass mr, so that's capital mr, where mr is bigger than little mr, so your Y rocket is bigger than your X rocket, mass-wise, will be launched vertically upward with the initial velocity v naught, so they're starting at the same initial velocity at time 0, until it reaches the maximum height. Ry will then descend vertically downward until it reaches the ground. Two students in the group make predictions about the motion of rocket Y compared to that of rocket X. Their arguments are followed. So they've done rocket X. They know what rocket X is going to do because they've seen it. They're trying a bigger rocket using rocket Y, and they're trying to predict what rocket Y is going to do compared to rocket X. So student 1 states, rocket Y will have a smaller maximum vertical displacement than rocket X, although it is launched upward with the same speed as rocket X and has more kinetic energy than rocket X. Because rocket Y will have a smaller maximum vertical displacement than rocket X, I predict that it will take less time for rocket Y to reach the ground compared to rocket X. So let's write down some comparisons just so we can get some visual, because sometimes words confuse, at least words confuse me. So I want to just kind of get some visual aspects on what student 1 is saying. So rocket Y will have a smaller maximum vertical displacement. So that's what they're saying. So we're saying the height of Y is going to be less than the height of X. So that's what the student's saying. Although it has a launch upward with the same initial speed. So they are saying it has the same initial speed. Same. So Y has the same as X, which was stated, so that's true. Has the same and has more kinetic energy than rocket X. So now they're saying that the kinetic energy of Y is going to be greater than the kinetic energy of X. Because rocket Y will have a smaller maximum vertical displacement than rocket X, I predict that it will take less time for rocket Y to reach the ground compared to rocket X. So now they're saying that the time 2 is going to be less for rocket Y compared to rocket X. Okay, so that's all the statement. So that's all the things that they're stating. And just remember, we already know that the m rocket Y's mass is greater than that. So that's something we know, but he's stating all those, and we know that, and we know this. So we know this, and we know that. Everything else he's predicted. So that's for student 1. Let's do student 2. So student 2 states, rocket Y will have the same maximum vertical displacement as rocket X because both rockets have the same kinetic energy. Okay, so now that he is saying that the heights are going to be equal. Don't forget that the initial velocities are equal. And he's saying that the kinetic energies are going to be equal. Don't forget that we've already stated that the m's are like that. So remember, this is the two things we know. Since both rockets will have the same maximum height, I predict that it'll take the rockets the same amount of time. So unlike this dude over here that's like, there's going to be some discrepancies, this dude's like, everything's the same. Everything's the same. Okay, so that's what we have so far. So for part A, ignore whether the student's predictions are correct or incorrect. Do not simply repeat the student's arguments. So you're not repeating the arguments. So just answer the question straight out. So which aspects of student 1's reasoning, if any, are correct? So which are correct? Well, he made the statement. So I guess, okay, so hold on. So he stated that, but we know that's true. He did not state that. He did, and the two I circled. So we'll leave the circled ones he did not state. He actually did state that the initial velocities were the same. And we know that is true because it was stated in the little pre-thing. So we know that this is true. And of course, you would want to put this into a sentence. And I'll read like an example of sentence, but we're just kind of jotting down. So we know that that is true. Another thing that we know is true is our kinetic energy. We know he's right on kinetic energy. So let's think about what is our kinetic energy equation here. Our kinetic energy equation is 1/2 mv squared, right? So it has the same velocity. The velocities are the same, but we have an increase in mass. So if we have an increase in mass, we have an increase in kinetic energy because that is a direct relationship. So since your mass of your rocket Y is greater than your mass of your rocket X, it's going to have a greater kinetic energy. So we know that's correct also. And that's about it. We don't know. We can't mathematically prove. Like this was stated in the problem. So this was stated in the problem. And this we can prove by an equation. The other two things we can't really prove right now. So we don't know. So if you want to put that into a sentence, it could sound like student 1 is correct that the rocket Y is launched with the same upward speed as rocket X. And since rocket Y has a larger mass than rocket X, rocket Y has more kinetic energy than rocket X. So it can be as simple as that. Now, if you want to go to prove, because it did say explain, I don't think that necessarily is an explanation. But that is like an example that they're using as an answer. So I would go and take it a step further because it says explain your answer. And so say a student 1 is correct that the rocket Y has a launch of the same upward speed as rocket X as stated in the problem in the paragraph above. And then rocket Y has a larger mass than rocket X, so therefore it does have a larger kinetic energy due to the kinetic energy equation ke equals 1/2 mv squared. Your velocity is the same, so the only thing that changes is your mass. If mass increases, your kinetic energy increases, which is a direct relationship. So kind of the more you can add to it, the better, because you can prove that you are knowing the information. Because you never know what they'll give you points for. You never know. Like that one question, I think it was, we were talking about forces, it was projectiles or something. It was forces and projectiles together. And it randomly wanted to give me your points for putting time. And it was like, why do I need to, the question really didn't talk about time, but it wanted you to talk about that time part. So put as much information as you can. So now part 2. Part 2 states which aspect of student 1's reasoning, if any, is incorrect. So it did state that it was going to have a smaller height than x. It did state it was going to have a smaller height than x. If they have the same initial velocity and they're both on Earth, therefore it should reach the same maximum displacement. So remember, the mass does not affect that vertical displacement. So the thing that was wrong was, we'll go back to our pink since we're doing it. The thing that was wrong was our hy is less than our height of our hx. And again, and I know I really said that you couldn't mathematically prove that. You could, and that was a bad statement. I shouldn't have stated that earlier. But so that's the part that he got wrong. And the reason is because think about, if you're trying to find maximum height, what equation you're using. You can actually find it not using time at all. So the equation I would use is your vy squared equals pre-p coming out, sorry, vy naught squared plus 2a, and you could, your y minus y naught. So remember, this is final, so this is just your final velocity. This would be your initial. That is your acceleration in the y, so that's just gravity. This would be your max height. And this is your initial height. That's your initial height. So as the rocket is going up, what is your velocity at the tippy top? Hopefully you said 0. Because at the very top, it stops. So your initial velocity at the top is 0. So if we're just trying to get max height, your final velocity is just going to be 0. We stated that the initial velocity is the same for both, plus 2. They're both on gravity. They're both in gravity, so it'd just be g. And then we're looking for the maximum height, and they're both starting at a height of 0. So this equation is going to be the same for both the y and the x heights, because they're both stopping at the top. They're both starting with the same initial velocity. They're both on Earth, and we're trying to find y. So they're actually going to end up being the same. And so a way you could word that is student 1 is correct in saying that rocket y will travel a smaller maximum vertical displacement than rocket x. Both rockets have the same initial velocity and the same acceleration. Therefore, they will reach the same maximum vertical displacement. The mass of the rockets do not affect the maximum vertical displacement. If you want to throw this equation in there somewhere, and it's kind of break it down, that'd be probably a good, just, that more explaining your answer type of thing. But yeah, so there we go. So that's breaking down student 1. So guess what we get to break down now? We get to break down student 2. So which aspects of student 2 reasoning, if any, are correct? So let's go back up to student 2. Well, we just proved the height part for student 2. We just disproved the kinetic energy part of student 2. So student 2, so it's to be the same vertical displacement because they have the same vertical velocity. So kind of it's this part just kind of repeat. So this is correct. And you would kind of, the reasoning is that reasoning. Now, I would restate everything. I wouldn't just draw an arrow like I did. I would completely restate everything because you don't want the grader to have to move around too much on your paper because they're having to grade thousands. So I understand it's going to be time consuming, but I would just restate everything. And literally you can restate, you just change from student 1, student 2 is correct because, and then restate what you said. But yeah, so that would be that one. Then for, we're in part I. And so we're looking for what's incorrect. And again, you can sit there and kind of look at what's above. So a couple of things he said that was incorrect. He said that the kinetic energies were the same. So we know that they're not the same because, again, because of our kinetic energy equation. So if your mass increases, your kinetic energy has to increase. So yeah, so, and you're going to state student 2 is incorrect in saying that the two rockets have the same kinetic energy. Even though the two rockets have the same initial velocity, they have two different masses, and in the kinetic energy equation, mass does play effect, so therefore the initial kinetic energies are different. So there we go. So now, question B. Use quantitative reasoning, including equations as needed, to derive expressions for the maximum height reached by rocket X and rocket Y. Express your answer in terms of, we had a double, V naught, so we need it, so our equation can have V naught, little mr, which remember that's in our X direction, big mr, remember that's in our Y direction, and any other function, so that's like we can leave gravity, worst case scenario. And then we're looking for our height X and our height Y. So that's what we're looking for. So since we're having mass and velocity and gravity and we're looking for height, only really system that works for that is our energy system. So remember, so we can use our conservation of energy. So energy before equals energy after. So we're going to put just F for final. Or here, we'll do before and after. So energy before the action equals the energy after the action. So what type of energy did it have before? So scrolling up here. So before, so as it's being launched, so right here, it's going to have kinetic energy. And as it gets to the very, very top, it's going to have gravitational. So if we're just going from before and then after would be at its height. So it just has, it's our initial kinetic energy equals our gravitational potential. So that would just be 1/2 mv squared equals mg delta y. Now it's according what, now does it matter on which mass we put in? Nope, because our masses cancel. This is another way you could have proved that the heights would have been the same if you didn't want to if you wanted to stick with the energy theme and not use this equation, you could actually have also used the, kinetic at the bottom equals your potential at the top. So you could have used that equation too, if you wanted to. But either one works. And so at this point in time, because we're solving for our height, so we can't actually break this down into our y equals y naught. Y naught just going to be 0 because we're starting at the bottom. So we're left with that. Now we're just trying to try to get y by itself. Here, y equals y minus y naught. I'll plug that in. Okay. And then, so y equals v squared over 2g. And specifically, it's our v naught, right? Because we had b in these terms, so we want that to be v naught. So, and then you can sit there, and if you wanted to do like a little explanation, it'd be the same for x and y because the masses cancel. And they start at the same initial velocity. So there we go. So they said you could use the masses here, but remember, just because they said you can use it doesn't mean you have to, because the masses ended up canceling. So that's our derived equation there. Hot diggity. So the next part, it says, so another use a quantitative reasoning, including equations as needed to derive an expression for time as it takes rocket X and rocket Y to reach the ground after reaching their expected maximum height. So we can use this one. We can use this one. Express your answer in terms of, we can use V naught, we can use MR, we can use big MR, remember that's X, that's Y, and we can use, I like how this one specifically says we can use G, and then any other fundamental. Okay, so we're trying to find time. Sadly enough, in our energy equations, there's no time in our energy equations. So we are going to have to kind of go back to our 1D motion problems. So this is where they kind of mix in like 1D motion with energy, and that's why I really think energy will be on your free response, because you can mix it with anything. So we need time. So we have a couple equations that have time in it. If you look at your formula chart. So we have our Vx equals V naught x naught plus AT, and we also have y equals y naught plus V naught. I guess it should be x, not y. Y naught y. There we go. V y naught times t plus 1/2 a y t squared. So we kind of have those two equations. And I think either one of them would work. So we have, so our final velocity, because we're just trying to figure out the time that it takes, so the whole entire thing it goes, right? So we're trying to figure out the whole entire time. So if you remember, I know it's just going up and back down, but if you remember your final velocity, because we're doing it down here, final velocity equals just a negative version of our initial velocity, because it's falling at the exact same rate. So we can put that this is a negative that plus gt. And you can just sit there and solve for our t. Yeah, so we can sit there and solve for our t. So you'd minus that. So you get a negative 2 v naught equals gt, and then you just divide that equals t. So you get 2 v naught over g. So you would get that. And then for this one is a little more complicated. So we are, because here is like for maximum height. So if you're trying to find, so after this, you would actually end up having to double it because this is solving for your maximum height. So I wouldn't use this one because it just gets complicated. Well, honestly, if your final height, okay, we're going to try something real quick. Because in theory, your final height would just be 0, right? So if we do 0 equals 0 plus v naught t plus 1/2 g t squared. Nope, you're going to have to do the quadratic equation. Please don't use that equation. That equation is evil. So, yep, I was like, but technically you can use that equation. That is an answer choice, but you'd have to use the quadratic equation to get t by itself. And let's just not put more stress on yourself when you can just do a nice, pretty thing right there. So part D says explain how any correct aspect of each student's response identified in part A are expressed by your mathematical expressions. So it's wanting you to look at your answers in part A and talk about how it was proven using your mathematical expressions. So, of course, our energy our energy part sit there and proved that the heights are going to end up being the same. So you could say, like, because rocket Y has a greater mass than rocket X, and both rockets are launched at the same initial speed, so therefore the kinetic energy of rocket Y your rocket Y has more kinetic energy than rocket X. However, looking at the conservation of energy being applied, the masses end up canceling out, so it shows you that you have your final height. So basically what you're doing is you're putting so in this one, you're putting part B into words. So it's a relationship in part B. So you're just putting you're putting your work. So you're just putting your work into words, basically. So say, yes, I did state that the kinetic energy for rocket Y is greater than rocket X. So kinetic energy for rocket Y is greater than rocket X. However, using the conservation of energy equation, masses cancel. And then leaving you the fact that your heights are going to be the same. Something like that. Now you're basically doing the same thing. You're putting your actions into words for your kinetic energy. So again, kind of the same thing, since your initial velocities were the same. Since your initial velocities were the same, and the final velocity equals just a negative version of your initial velocity, and then both, so your acceleration's the same because it's gravity. Your equations end up being the same. So there we go. So that is the first question of your free response. I'll stop it there. I'll make another video for the second question. Hopefully that kind of helps. I try to sit there and break it down, like my thought process. That's why you see some things like, oh, nope, that didn't work. Try this. You notice that my brain goes to 1D motion quicker than it does go to energy. This question would be a good example of that because we could have totally just used the energy equation to prove that, but my brain automatically jumped to 1D motion. It's just and either answer would have been correct. You could have used that equation for it very simply. And so yeah, so hopefully if you have any questions, please don't be afraid to ask, and hope you have a good day. Bye. Part 2 to come.